Hello everyone, this is Shivadhanush. Today I'm going to introduce to the concept of how to construct NFA for a language. Let's get on right into it. NFA is non-deterministic finite automata. Simply put, it's similar to DFA, but you can have different, like multiple transitions from a single state to any other given state, and also um, we can also have epsilon transitions. And this multiple transitions can be w- um, for one single alphabet. You can do multiple transitions from a single given state. And the input is string and the output is yes or no. Okay. Coming to the phi tuple. NFA, if we want to learn about NFA, we have to have a certain set of rules. And phi tuple actually consists of everything summarized into one set of tuple. So in this tuple, you have the first element, a set S. It is a set of all states that we are going to use in NFA. And we also have the sigma, which is the input alphabet. It is a set of input alphabet. Uh, we also have the start state. It is a designated start state, and um, the program runs always starts running at the start state. Now, coming to the transition function, this is actually the set of rules that de- dictate how a transition occurs from each of every state. Now, coming to the set F, F is the set of final states. Here, there can be any number of final states, but you cannot have more states than what is possible in one NFA. It's very intuitive in that regard. Um, we need to have a set defined set of tuple. Now, coming to the problem, so uh, we need to actually solve multiple problems to actually know how to construct NFA for many different given problems. So I'm choosing a different problem. I'm choosing a problem which has a different method of solving it. So let's get right on it. So for the problem that is given here, we need to construct NFA for this language. We need to have W. W does not contain the substring 110. Now, what does this mean? It W accepts any string that doesn't have the substring 110. So, what is the idea for construct an NFA for this? Let's say we have given uh, a problem, a language that only accepts the substring 110. Now that is easy because that we have done in DFA as well, and it's very simple with the following state diagrams that I'm going to show you. And based on that, we can build up back to the given problem by simply exchanging the final states with non-final states and the non-final states as the final states. So this is my approach to the solution. So it might be not clear with the tuple that is presented, but this tuple is well defined and it doesn't have any ambiguity. So that means just by looking at this tuple, you will be able to identify that there are specifically four states. There's one final state and a transition function that is depicted in the table right here. So state diagrams are very easy to understand. Based on the state diagrams, you can understand that we have S0, which is a start state, where n- uh, where we accept all kinds of zeros and ones, but we also check for any possibility of getting 110. That is done by S1, S2, S3 states. So when we get 110, we accept that uh, string, and we don't care about the rest of the um, substrings that follows after 110. Now, now we need to complement the previous state diagram. So how do we do that? Mm, As I said earlier, we need to exchange the states which are final states with non-final, and the non-final states is final states. Once you have done that, and as shown in the state diagram over here, you can see that the uh, the state diagram, the whole NFA that have built over here, accepts all kinds of strings, but when it comes to 110, it simply rejects it. Once it is rejected, it can never be accepted again. So that means any string that has 110 will be straight up rejected. This is the tuple that follows with given the previous state diagram. So in this tuple, you can observe that the final states are S0, S1, and S2. So that means we will be accepting any any string that doesn't have 110. That includes epsilon. That's the reason why we are accepting at S0, which is the start state. Now, coming to the transition function, it is exactly the same as the previous state diagram, where we didn't accept any string that has 110 as its substring. I would recommend to check the authenticity for any kind of NFA that you are trying to build. Let's work with some inputs. We have an input over here that is 10011, which doesn't have the substring 110. So will this work for the input? Yes, it will. So by the end of the check, the possible states for the system can reach as S0 or S2. So it never reaches the accept state, which is SC, S3. Okay. So, sorry, the reject state S3. Now coming to uh, the other string that I'm taking here, which is 00110010. Now for this string, we have a substring which is 110. Now NFA has the property that it will reject any string that has uh, n- that doesn't that goes to the sync state at any given time. So when you're checking for the given string, right? So you keep on going with the let's look at the diagram, state diagram itself. So you can see that at S0, you keep on rolling with the zeros and ones. And if you draw the tree, you can see that it might the given string in the second case will be accepted at some point, but will be rejected at one point, because since it has the substring 110, there is a possibility that it will reach S3. So it will be rejected at that point. Now, closing remarks. I would like to close this with some important points that needs to be taken note of when you're um, constructing NFAs. So the first one would be to identify the number of states. So when you're looking at a given problem, I would suggest you to uh, formulate the number of states that the given problem might need, because the number of states uh, that we are trying to build the NFA with dictate how efficient the NFA is going to be, and how easier it is going to be to create it as well. When you are clear with how many number of states you are going to build the NFA with, it's, uh, it becomes the rest of it is all easier. Now you need to have a clear idea of what the problem states when you're giving when you're trying to make an NFA, so that the states can be clearly identified. Now always check for the authenticity, as I have mentioned earlier. When you're done with constructing your NFA, please look for any other um, possible strings that you can come up with, and keep on checking for the authenticity, so that the rejection is firm. Like all the strings that the problem is asking for you to reject or accept, you have to do it, so that it doesn't become like you'll not face any problem later on. So this is it for my presentation. Thank you for listening.